I've taken time out of the FIP Showcase event to sit down with Johnny from AqSorption to talk about the project that he's been delivering. Johnny, thank you for joining us today. Would you like to introduce yourself and explain your company a little bit?
Yeah, sure. I'm the commercial director at AqSorption. We're a mid-size, small-size, Nottingham-based engineering company, and we specialise in electrolysers and electrolysers for unusual use cases as well. They're very robust, and they particularly suit things like isotopic separation for fusion.
Fantastic. Could you talk us through the Fusion Industry Programme Challenge project that you've been doing for the last couple of years?
Yeah, there was 2 phases. So the first phase was we took some research that was from the University of Manchester about separating isotopes and concentrating deuterium and tritium, and we applied that learning to the electrolyser build and design itself, and we built some small-scale rigs similar to this. And inside there's a membrane-free design, and you can get flow-through electrolysis and separation of your isotopes just through electrolysis or from using particular membranes. It took us a while then to scale that up to the phase 2, where we've built much larger cells and found that quite a lot of the materials that you would typically get in an electrolyser needed to be swapped out, so there was a lot of a materials challenge as well to get it suitable and compatible for handling heavy isotopes.
You've clearly made a lot of progress. You've brought us interesting things to look at. What are the rest of the things that we have here today?
Well, you have a stack, so this is just a small electrolytic stack. So part of what we were engaged with doing was looking at a pulse DC power supply into electrolysers. A slight issue with electrolysis is it is quite energy intensive, so anything you can do to make it less parasitic in terms of its operation is ideal. So this was really for us to optimise our power supply, which we managed to have done, and as another benefit for that, we've managed to have dropped the caustic solution that we use in the electrolyte down from 15% to 1%, and so the longevity of everything is much improved.
And what do you think are the next steps for your technology now that you've come this far? What do you hope to achieve in the near future?
Well, we hope to build large-scale devices really that are capable of shifting large amounts of water. So there's applications in the detritiation of water, there's applications in the handling of gases themselves. We've had success with building a gas cassette as well with the University of Manchester, and the graphene centre we've proved out separation factors that are very high, and therefore we can operate both in a water phase and a gas phase, and therefore you've got a flexible tool really to get your isotopic separations to the ceiling and the harvesting of the level you want. So the idea is to build the kit really, to prove it actively with tritium, and then to enter commercial arrangements for people that need such things, including Culham, but then there's also applications even within the fission industry in detritiation.
And is there anything specific with the FIP funding that you received that enabled this technology to get to this stage?
Absolutely vital, really. It was, there's no 2 ways about it. We managed to have, as a small team, been focused really on research, managed to build a great system of laboratory technicians, process engineers and the like, and that's entirely down to the FIP funding. And we're really excited about the fact that we've can focus not only in green hydrogen production, which is our daily focus as well, but in producing something that does something really quite unusual and is a marked improvement on what's existing in current isotopic services.
Thank you for bringing all this interesting stuff with you today, and the team as well, to the FIP Showcase event. It's great to have you here.
Fantastic. Thank you.